Welcome back to the power supply project. In this video, I'm going to be creating the PCB design for the boost converter, which we created in the last video, if you remember. So we went through the schematic creation and the design calculations for a 24-volt boost converter and also the minus 24 volts inverting converter as well. So obviously both of these are taking the input voltage from the 5-volt power supply line. However, what I'm going to do in the next video is change this input to connect up to this point here. I'm going to add in terminals for the 4 AA battery cells, and obviously I've already got the terminals for the rechargeable lithium ion battery, which are on this cell here. So I will add in a switch such that I can select the power supply going to this converter over here. And then this converter will basically drive this one and this one. The main job of the USB-C converter will be to connect to this here. I will also have another switch where I can bypass the boost converter over here and connect this directly to these 2 points. So the whole point of this is that I can select as a power supply for the board 5 volts USB, 4 AA cells, or a lithium polymer battery. So hopefully that will give me a lot of flexibility on what I can do. And obviously if for the output voltage we got 5 volts, we got 24 volts, minus 24 volts, and then the last thing that I'm going to make is a 3.3 volt buck converter as well. So let's now go to the PCB design for the boost converter, and in the next video I will basically do the inverting converter design. I'm all doing it as small sections at the moment, and I will bring it all together right at the end, which hopefully won't cause too many problems. I mean, if I was doing this for a real project, I would probably approach it very differently, just do the schematic first. So moving on to the PCB design, I'm going to take away the square box and hide the inner layers for now, and update the schematic with all the new parts that we have. So if you remember from the last video, we did the footprint assignment tool as well. Obviously there is the coupled inductor that we need to create as well, which is for the inverting converter. So I'll need to do that in the next video, not this one. Putting my schematic and the PCB design side by side, I can see U4 is for the boost converter. So I'm just going to select that and move it out. And then L2, which is this one. Right now, let me just quickly show you the bill of materials for this. So on the screen now, you've got the bill of materials for the boost and the inverting converter, which there are some shared components from the previous circuits that we did, namely the buck boost converters. So I'm reusing the 22 microfarad capacitors and the 100 nanofarad capacitors as well. So the first thing I'm going to do is make the footprint for the inductor. As I can see, this one does not match the recommended line pattern from the datasheet of the component. So the pad size for this is obviously 6.6 millimeters, whereas the recommended is 3.4 by 1 approximately. So what I'm going to do is create a footprint for this component over here. To make a component footprint, what you need to do is go into the footprint editor, and as I've never created a new footprint with KiCad 8, I'm going to make a new library as a global, and I'm going to call this my library, as it's easy to follow. So you can see I've got my new library created for the footprints, and in there I'm going to make a new footprint and name the footprint after the part number and the manufacturer, so that it's easy to find in the future. So XGL 4020 222. Now the first thing you see is the 2 LAN patterns for the connections to the inductor, and what I'm going to do is position them as minus 2.37 divided by 2 and make the size 1, 3.4 by 1, and then copy that and move it to here. And then I need to, for the position, I'm going to do 2.37 divided by 2 on this as well. Now is to change that to pin 2. The last thing I need is the courtyard for this. which is obviously going to be the 4mm dimension that you have here. I'm also going to include the tolerance onto that. So that will be 4.3 divided by 2, which is 2.15, so 2.15, and then both of these will be minus 2.15. The height of this is going to be 4.3, and the width is also 4.3, as you can see from this drawing here. Firstly, I need to change the grid size to position it accurately. However, the best way to position it for the start point would be to use this. If I'm calculating correctly, it is basically 4.3 divided by 2, so it's 2.15, 2.15, and then this will be the positive 2.15. Finally, I will just add in some silk screen, and this is when the component comes on, it'll be easier to see where the component should be placed. So again, using the same calculations, 2.15. So you can see now I've got the silk screen on this as well, and the pad sizes match this basically. And I've used the biggest dimensions that are possible on this. So that would be 4.3 as the key part region. So I want any components to be at least outside the pink line that you see on here. The silk screen will just make it better to see where to put the component. So I've saved that, and basically to assign that back to this footprint here, I will need to go back to the schematic. So if I go to the schematic editor and then run the footprint assignment tool, and in there I will go to basically my library and change that to this part there. So you can see 4020. After the footprint assignment tool, basically update the PCB. So open the PCB editor, and I'm going to delete this part and update the PCB and put this part back on. So you can see now I've got the inductor here, and this should match up to the size that we designed. Again, putting the schematic and the PCB design side by side. Just going to try to match the schematic for now. So I've got the inductor on top. Got two components, so C13 and C14 on the input. And I've got D3 after the diode, after the inductor, sorry. And then I've got C15 and 16. Because you can also see I've got R11 and R12 that need to go in there, so I'll just go get those two components. Obviously at the moment I'm just doing a rough design for the PCB. And then finally I have R13 and R14, and then just these three capacitors here, so C17, 18 and 19. Now just looking at those, I can see they don't look quite the right size, so I'm just thinking maybe I've put them as wrong sizes, so they should be 0402. So I'm going to go into my schematic editor and correct that. Run the footprint assignment tool again and look for C17, 18, 19 and change them to 0402s. So apply, OK, open the footprint editor and then press the update button. Now just bringing the schematic and the PCB design side by side again, you can see I've got C13 and 14, got the inductor, got the diode, got the two output capacitors, got the feedback network, and then I've got 1, 2, 3, 4, 5 components at the bottom there. So 1, 2, 3, 4, 5. So I think I've got all the components that I need for the boost converter. and I can do the design. So what I'm going to do now is do the PCB design for this part. I think the hardest part is getting the layout correct. So if your layout is approximately right, when I say layout, I mean the placement of the components. If you get the placement correct, the tracking should be easier. So if you spend a little bit more time on the component placement, that will make your job a lot easier when it comes to the tracking. So I'm going to start the PCB design now and do the tracking. Sit back and enjoy, and I'll see you at the end. So you can see now I've done my PCB design. What I need to do now is basically correct all the silk screen, because I hid that when I was doing the PCB design so it doesn't get into the way. So putting the silk screens back on, you can see it's a complete mess. Obviously the silk screen is also quite large as well, so what I'm going to do is just bring it roughly to the right place and then resize it as well. To resize the silk screen, go to edit text and graphic properties, and click on reference designators and change the font on front silk screen to 0.7, 0.7, and 0.15. I'm doing a 4-layer board here, so the inner layer 1 is the ground, so all these wires are going to the ground plane. And obviously at some point I will need to connect the V-bus, but I'm going to disconnect this and connect it to the 5-volt rail with the switch as well, as I spoke about before. So this is the PCB design for the 24-volt boost converter. You can see it was fairly simple to put together. Let me show you what this looks like on the 3D viewer as well. So you can see our LT3448 component, which is here. We've got our diode, SOD123, our 22 microfarad capacitors, the feedback network, which is R11 and R12, and some surrounding components for the soft start and the frequency timing and things like that, which obviously we spoke about in the last video. You can see there's no model on this for L2. You can download 3D models from online, and I'll show you how to add a model to this footprint. To add a 3D model to this footprint, what you need to do is click on the part, press the E button for edit, and then go on to the 3D model tab over here at the top, and then press the plus button and the folder button here. Then you can navigate to wherever you are holding your 3D model. So in my case, it's over here. Now you can see this is rotated. So you can basically go onto this and rotate as you need. You can see this is lined up very good. So I'm going to press the OK button. And then finally, show you the 3D viewer. So over here we have the buck boost converter. Over here we have the lithium ion polymer battery charging circuit using the TP4056. Obviously we got USB-C connector. I will basically have 4 or 5 headers here. So one for 5 volts, one for 24 positive, one for 24 negative, and then one for 3.3 volts on this side. So at some point I'm going to bring this out and also this output. You can see the circuit is coming together now. I just need to add in the inverting converter for the minus 24 volts and the 3v3 buck converter and a 3v3 LDO for low noise applications if I ever do anything in the future for that. So thank you for watching today, and obviously if you have any questions or any suggestions for what I can do differently, please let me know in the comment section below, and I'll see you next time.